of the things that I did is I had an existing blueprint class. Let's go back to, let's close this, save this. Okay, let's go back to my level. I'm going to bring up the content draw, and I'm going to right-click in here, and I'm going to create blueprint class. Now, the other way you can go is up here, button up here, new empty blueprint class. And it's going to ask what type of class is it going to be. Again, for our purposes today, we're playing with actors. We can create classes of other classes, but right now we're going to work with just the actor class. So I'm going to click on actor. It's going to bring up, hey, where do you want to place it? I'm just going to put it at the root of the content for right now. And I'm going to call this light P. Oh, yep, because that's what the we're calling it hello light because that's what we've been calling it in our documentation.
Oh, you put it in the search bar.
Oh, I put it in the search bar. Oh, I'm sorry. What I want is put the name down here. There we go. Okay. So I'm going to click save. And it's going to bring up this new window. All right. When you start off, you will get a scene root. All right. So scenes, basically, think of them as like folders, or in Unity, an empty game object. If you want to move a group of things around, make a scene to control it. Right. There is a default scene root. Now, we can override that. And actually, one of the first things I'm going to do is going to add a cube. And one of the things that I can do is I can take the cube and put it up here, and it will make it the default scene root. So everything will be relative to the cube. I'm actually not going to do that because I actually want the scene root. But I could make this everything relative to the cube. There are reasons why you don't want to do that. That make you like when you have something that's a visual element of a class, it should be it should be a child of something as opposed to everything else. The other thing that again we'll add in here is the collision box collider, and we'll use this for we'll turn this around. We'll turn this. This will be hit F2. This will be the trigger volume. I'm just going to do F2. I'm going to call this platform. And we're naming these so that we know what they are, what their purposes is. I'm going to add in like I typed in light. I'm going to put in a point light. And it came in as a child of the platform. I actually don't want that. I just want to just detach it. So I'm going to put the I'm trying to like there we go. So again, I've added the objects right here, and again, I didn't show you how to create the object in the first place. So platform again, I'm going to go and put this as 0.2. You can see that it's basically 1/10 is going to be in the ground and 1/10 is going to be above ground, which I'm fine with. You will see that there is still the, if I can get it, there is still a default scene root. That's this object right here. I'm going to take the trigger volume. One of the things I want to do is there's a box extent here. And right now at scale 1:1, it's basically 32 units out. Hooray, this is old school power as a 2 grid thinking. The box really is actually 50 if I want to keep it a cube. This cube right here, its extent is 50 by 50 by 50. Now I've made it 0.2, so now it's 50 by 50 by 10. I'm also going to move this up 50. And so it'll sit basically on the platform nicely. So as I decide to scale the platform later on in the editor, it will these objects. So what I'm doing is basically making a standard scale between the platform and the cube, so that when I go and decide to scale it later in the editor, it's going to be uniform. Grab my point light, pull it out of the ground, and I'm going to do this 150 for the sake of argument. And I'm going to make this red. Type in the value itself. And you can actually go super. If I do a 2.0, it's allowable in Unreal. It means that that light is now super intense, is basically the best way to describe it. Basically, in an HRD, it's allowed because we're dealing in an HDR setting, so it'll be a much more intense red coming out of that light. As you get higher, that becomes meaningless. It becomes basically a white light. If you go like 50 here, it'd be a white. The light you would see would be white. So, but I'm going to go back down just to 1.0. And I'll click OK, which I did not do a couple of times. There are things you can play with, like, hey, is it unitless? Are we working with candelas? Again, we're working with like 8 candelas here. We found that 100 was better. You can deal with lumens, EV, unitless. So there's other options. Attenuation radius. This is how far the light is going to affect things, and this is huge. I probably want this 200. Just more. I want to keep the surface of the in here. Bring it down to 100. I'll leave it like that. But basically, I'm going to, my attenuation is going to be 200 units. So I'm going to hit the surface of this, a little bit around it, but not as much distance. And this is a way to control, like, you can have a very small, bright light, but doesn't illuminate the whole scene. A great example of this would be like the power buttons on, power buttons on your machine would probably be a texture. But like if you wanted to simulate something with the glow of a monitor, that would probably be a point light that I would probably use and play with the values of the light. Question.
What about, would this be useful for, let's say, like an illuminated button in a dark room, for example? Or would we use
Depends on the button.
Like, let's say it's
we're talking about lighting. We're talking about, so there's an idea that materials can be emissive, and I would probably be playing with a material that's emissive in a dark room. Like there's a red button, it's emissive. I can see it in the room, as opposed to giving it a light. And that's a lighting theory question. So I don't want to get down that rabbit hole right now. I want to pull us back here. But essentially, this is our object. It is the platform, it's the light, it's the trigger volume. And it was basically the same 3 objects that we had in the scene before, just now in one object. And I'm going to compile to bring them all together. I'm going to click on the trigger volume, and I'm going to go to the event graph. And there is, again, event begin play, actor begin overlap. We're actually not going to use that. And then there's the event check. We're actually not going to use these. So when I right click into the scene this time, it wants to select a component. We want the trigger volume. There we go. And then add an event for the trigger volume. Now there are over here events, because we selected the trigger volume. The details panel showed information for it. So this is one of the things where where things get crazy really quickly. There are properties like there are properties for the class itself. So if I click on hello light, there's property here. Here's the trigger volume, and there are details here. I click on trigger volume here. There are other details related to it here. Right now, what I want is I want the on begin component begin overlap. So we're talking about begin overlap, but for components. So this is when something overlaps this component. For example, a player walking to a trigger. And that's what we want. I'm going to click on the trigger volume one more time. The other one we want is end overlap. I'm going to bring this down here as well. So we've got all sorts of information from here. There is, what is the overlap component on the other object? What is the other actor?
The player.
It could be the player, but not necessarily. Again, remember, a physics box is an actor as well.
Any character, any other object.
It could be this is where you if our trigger was wanted to be specific about what actor it wanted to deal with, this is where we could check against that actor and see what type it was. Moving on. The other component. So there's what is the other component that you that's overlapping this component. Other body index from sweep result. You can look up these. I've rarely, if ever, touched these at all. It's always been these three. And then down below we've got the overlap component, the other actor, the other component, other body index. Big deal body index. I've never really used this, but I've used these three in various ways. All right, I'm going to go back to my point light. I'm going to click on the light here, and I'm going to right click and I just need to drag this into the scene. And I want to get my point light. So I'm getting a reference. Now later on we will set things in the next part. But basically right here, I'm going to get point light set visibility. I'm going to drag that up here. I'm going to copy and paste and bring this one down here. So the light, again, the target is this point light. And this is my begin overlap, so I'm going to plug that in here. I'll turn this one on. On end component overlap, I'm going to tie them together, and I'll turn that off. The other thing I'm going to do is I'm actually going to do event begin play. And I'm going to wire that into here. And think of this as wiring. All right. These are the exec nodes. This is the order of things of operation. They flow from these events through nodes. Now, nodes like this point light are different. They're variables, and there's operations. Essentially, this is the ultimate, like, what are we information. And you can do lots of different transformations on these as needed, whether they're mathematical or conversions from one class to another as see fit. Or one of the things that again, I showed you is that were the pins for like a transform. We were able to break that into its scale, location, and location, scale, and rotation. Excuse me. Location, rotation, and then finally scale. Again, the vector, the location is a vector 3. We were able to break that into its 3 vector, and there are times when we will do that. Where that will be information and it's something that again will come up time and time again. So I'm gonna compile. I'm gonna go back to my scene, drag that here now, and I'm gonna go and save all. And this is, you'll get used to saving everything over and over. This is, I'm gonna take you out of the scene, and I'm gonna go back to my content draw. Class, hello. Okay, this is the one we want. And And you can see right here, I've just dropped that into the scene. I'll make this twice as big. So there are things that I need to do, like again, the light has, again, everything got bigger. I'm gonna bring this down a little bit. So here are my pieces. I can actually go look at the point light. I can bring this down. I'll make this 300. Again, I'm gonna just duplicate it. Duplicate. Not duplicating that. Okay, I'm going to make another one right here. I can go to the point light and I can set its value to yellow. Now, paste this one over here. I'll go to this point light and I'll bring in and when I press play, let me see, where's my player start? I take my player start and I'm going to bring it over here just so to make my life easier. See, boing, boing. And you can, again, some of you were doing this already. You can see that with just duplicating the entity and whatnot, I got what I needed. All right, this is actually your first part of your lab, is to recreate this with blueprint classes. And to put these down, and I can go now and be like, all right, I want this to be scale. Here we go. Make you wider that way. I'll make you wider this way. Over. So now I've got. Let's go back. Oh, because I touched the platform. I wasn't playing with the whole object in that case. So here we go. Here we go. Let's say I need this taller. Again, point light, need to go in. We'll give this continuous, say 500. Grab you. Over a little bit. And then I can press play. I don't need to recompile because those are the entities. You can see them in action. You can see this one's bigger because I've scaled it up. All right. So far, so good?
I have a question.
Yes.
Or
What's up?
two questions. So those are the blueprint class are pretty much just like prefabs, right?
So the term prefab comes from Unity. So that would be, like at the highest level of Unity, you're creating prefabs. Those would be entities. Blueprints. So your entity could be a blueprint class, it could be a C++ class, it could be a mix of the two.
Okay.
So just be mindful that there could be other classes that you're inheriting that are building up that blueprint class.
Right.
Conversely, again, later on, we'll build a blueprint class that can be inherited by other blueprint classes.
And that was my next question too.
Yep.
So for that blueprint class, can it interact with other blueprint classes, or is that something the level?
No, because there's nothing. The answer here is going to be no, because there's nothing for the blue. In theory.
Like, can it reference another one, or is that
So
something
it's different. So there's two different questions. The way that we built these are like singletons, serverless signature jacks. They're doing one thing, and that's what you want to think about in terms of when you're building things like does it single purpose. right now these blueprint classes, I think, let me grab this one for this sake of argument. Let me just overlap these two. I think, no, they're not. They're not reacting to each other. Okay. I thought they might react to each other, but they're not. And that's, I believe, yeah, I think something's set on. They're not. We can change that. That the current the default behavior of the triggers right now are only looking at players. Um,
But could we get a reference from the others?
oh yeah, no, later on we will write things that you can write. Not another specifically blueprint. So think of blueprint as the means, like C plus C sharp, our language. Blueprint is our language.
Mhm.
Can we get a reference to another actor? Absolutely.
Okay. Gotcha.
Can we assign, like, again, one of the things that we could do is let's see. Let me. We could in theory basically like have the trigger set up the trigger, and then the trigger basically it's scripted to basically um, doesn't have the light point in part of it, but the light is something we could assign to the object. Let's actually do that. That'd actually be really cool. An actor trigger. I want to say light, and I know that's really small because I've got the. So basically, this is going to be light assigned, and so in this case, we're only adding the cube, which we're going to make 0.2 again. We're going to add the box collision, which we're going to move up. And we're going to make this 50, 50, 50. Okay, there we go. So basically, we're going to set it up in this particular way. What we are going to then do is going to create a variable, and we'll call light. Yeah, let's call it light. And it's going to be. We can actually look for a light and ask for an object reference of a light. So we actually ask for a light. Again, all of the lights. So there we go. So I'm going to basically just turn off the light. Let's go to the event graph. So for our purposes, grab all of these guys. Actually, we'll just grab. Hold on. No, we're just going to use begin play, and we're just going to turn it off. But in this case, we grab the light reference here. Get light. Again, it's going to look different. The one thing that we need to go in here is actually make it editable instance. So basically, this is equivalent. For those who are writing C# code or C++ code, this is like equivalent of making it public. All right, and I'm going to go back, and then I'm going to be set visibility, and give me another reference of the light. I'm not sure why. And then just plug in begin play, and I'm just going to turn off the light. So I'm going to go back into my scene this time. Make sure compile. Use Control-Shift-S, so save everything. You'll be doing a lot of save everything. So I'm going to go, here is the light assigned. So I'm going to bring in the trigger here. And this is, again, I'll make this 3, 3, 3, not 33. There we go. Again, nothing's happened as of yet. If we go to the output log, it probably should say, yeah, runtime error, trying to access property light. So what happened here in that case, here's the error. Basically, this was trying to do something, and this wasn't set. So it's like, well, it's like I was trying to do something, but I didn't have a value to work with. Again, this is basically, we'll click on the light, actually log it, click on the light, and I can assign it. So now this light, this is going to be the, give it a value. So here's the assigned light object, and you can see the name changed. So it's underneath the hood, these objects have identifiers, and then they have names. And those names are for our purposes. It's for, when it displays like, hey, this object, if we print something out to the console, like this object did this. That's part of the object's name. And that's something you get, I believe, if it's not at the object level, it is at the actor level. So it's something that's internal already that we have access to. So now that I've got this site set up, I press play, we turn around, it didn't turn off, why? Oh, no, it's setting the actor hit in the game. Set. I got the wrong component of the wrong node. There we go. I was trying to hide the actor in game, as opposed to, which is it is already, as opposed to setting his visibility off. So I compiled. I hit the wrong node when I compiled. There we go. So let's go back. So now when I press play and I turn around, you can see that the light is off. Now we can go back in. So here's begin play. I'll click on the box. Actually, click on the box down here to do the end overlap. I'll plug that in there. Grab these three nodes. I'll copy and I can paste them. And I'll bring in. We'll click on the box again. And here again, your common events are going to be right here. So on begin overlap. I'll plug that in there. I'll set this to be visible. I'll compile, save everything. And now when I turn around, again, that's off, but I go in, you can see that. Hey, now I can basically assign something in the world to it. Again, this is a property. This default section is basically, we don't tell it what category it's in. Again, we can go back. Let's go back to the light assign. Let's go back to the light variable. And there's categories. Right now it's a default. We'll put it in gameplay, yo. And we will recompile just to make it to, and we go back to the level that now that category is now gameplay, yo. So you can control, you can create your own categories. And we'll do that a couple times. And those will help you find, like we can now search for gameplay. Over time, you'll find that you'll be able to do this here in Blueprint. You'll be able to do this in the C++ code as well when you get to that next class. Okay. So, any other questions?
So is there like a purpose to using the blueprint class instead of the level?
Yes, code reuse.
Okay, gotcha.
Yeah. This now I can talk. I can ask. I can query. I can query for all the. Well, I can query for everything of a class. Again, the example that they showed is that there was a coin class that they created, um, and for our purposes, like um, I'm not going to create that right now, but we could then create sub children. Actually, the way that the way that will work later on is that we'll do a small collectible game, and we'll create a collectible class, and then create children off of that collectible class to do be other type of collectibles. So we will start probably with a coin, but there's a statue and other things that we could potentially collect, and they could have potential other effects. There's things that we can do to make it modular, so that we can have them do different things based on what we want. Any other questions? Okay. So again, this is right here. This is your first part of your lab. Your second part of the lab basically is we're making a sliding door, and we're going to build. Let me see. I'm going to close you. Make sure everything is saved, and I'm going to go to my content draw, and I'm going to create a new blueprint class. It'll be an actor, and I'm just going to call this sliding door BP. And again, it'll be BP something or something BP. So make sure that you've got that in the name of your class. That's going to be very important, particularly when you start mixing between C++ and Blueprint. It's going to be very important. In terms of object name references, basically. All right. So basically we need 6 cubes to start off. Default scene root. I'm actually going to make another scene. Am I going to? No. Yeah, I'm going to make another scene just for the sake of argument. And this is going to be the door frame. Actually, I'm going to go back to. So I'm going to go back. Look at our lab document quickly because it might have information there already for you. So here is the lab. So here is talking about Hello World BP, Hello Light. Sliding doors BP. Read about the tutorial. There's something that they do. Do I give you? Oh, I don't give you the information. Okay. So there again, six cubes in play here. One for each of the side, top, bottom, and the doors themselves. So let's go in. So let's build the door frame. And just basically, we're going to add a cube. I'm going to make this point 2. All right. Remember, in Unreal, your forward axis is the red arrow. So we're going to build it sliding on the Y. So I'm going to make this length of 2, and I'll make this as a length of 6. I'm going to duplicate this, not delete, duplicate the top, bottom. So the top, I'm going to make this 1. I'm going to bring this up. And I'm gonna compile this. I'm actually going to go back into my scene. Where's my player start? So I'm gonna grab these out of the way for one moment. I'll pull these over here. And what I'm going to do is I'm actually going to go into my content draw. I'm going to drag this into the world. Okay. So you can see that it set down nicely. The shadow was throwing us off a little bit. So I can bring this. I know I can now bring this down. So I'll make this say 300. And again, this will make our lives a little bit easier. I'm going to take the bottom cube and I'm going to duplicate it. And I'm going to call this side. Okay, so we know that I want this to be slightly in, so I'll do 1.8, do 1.9. I want this to be one large, and then I think 3. There we go. So that should give us. Should be good. I'm going to duplicate the cube, and I'm going to say this is going to be door A. And I'm going to bring this out, and we know that we want this to be too wide. And just to make sure that the door reads a little bit better, I'm going to make it 1.8. I'm going to duplicate the door, and this will be door B. And so where the location here is 100 units in that direction, I'm going to be negative 100. So you can see how it's snapping into place nicely. And then I'm going to grab the other side, and I'm going to duplicate that. And I'll just make this negative 250. All right. I'm going to grab door A and door B and assign them to the default root so that I can just collapse the door frame. So I can look at just door A and door B and not worry. You can see there's all these different components here, each of the objects. Ideally, this would have been, the door frame would have been a mesh, and these pieces would have been a mesh. So the one thing I want to know right now is my door is sitting right here. Where should it be sitting if it's inside? Let's click on the door. Let's do door A. And we will try and assign it. So here's 300. Let's do 275. So here we go. We've got our door with a nice little lip. So the difference between, again, the value that we started with was negative 100. So basically, we're going to slide it 175. So that's something we're going to go down to our variables. We'll create a new variable. Do a slide amount. We'll turn that to a float. We'll compile, and then we can set the slide value down here to 175. So we know how far the door should slide. Now I can set this back to 100. I'm going to collapse the door frame. The other thing I didn't do is I didn't add a collision. And here's my box collider. All right, now you can see that my box collider is inside here. And I'm going to bring this 50, 50, 50. Actually, do 100s. So we can adjust the extents here, but I'm also going to play with the scale. So this will be 3 tall, 2 tall. So we'll bring this up. We know that there should be 3 wide. We'll do it like this right now. So basically, we're making the area where the door, so basically, when the player is inside this, volume, we want the door to open, and when they leave this volume, we want the door to close. Now we could say like one-sided. We can do something like that, but I'm going to just do generic both sides for right now. So this will be door trigger. Okay. So let's go in. Let's compile. Let's save everything. So we've got everything we need in terms of our components. So let's go into the third, our event graph. And we're just going to delete these guys. So if we go back to our third person map, you can see that here is our complete object at the moment. All right, so first thing we're going to do is we're going to go to the door trigger, begin overlap, and overlap. And again, we don't need begin play because it's going to start closed to begin with anyways. And what we want to do is right click here and type timeline. And so what we're going to do is basically so basically we're going to use what's called a timeline to control the door. We'll get over the math in one moment, but essentially is on begin overlap, we were going to play, and this is going to reverse. Now it could be reverse from the end, reverse from, there's options here, but essentially, when we enter this, it's going to play, and when it comes out, it's going to be the reverse. And then we're going to double click on timeline itself. We're going to bring up this new, and we need a track. And we're going to use a float, basically a float track. Basically, this is going to go from 0 to 1. So this is going to be percent. We're going to right click in here, add key to curve flow 0, and then we'll add another one over here, and then we'll set the value. So here is this one right here. We will set a time of 0, value of 0. And then this keyframe, we'll say, for now, we're going to set a time of 1. We'll set a value of 1. And that basically, and then the last thing that we need to do is our length. Let's say we're going to set this aside a time of 3 for right now. So ideally, we can go in and be like, this is actually a time of 3. So basically, we're going to open, it's going to open over 3 seconds. We'll do this 2 seconds. Let's do this quicker. So I'm going to type value 2 in here. Now I double click clicked on it, it's giving these handles. This is for Bezier curves. We're not gonna. We'll talk about them in a moment. We'll come back. We'll do like easing in, easing out type stuff in a moment. But I'm gonna compile. All right. I'm gonna close the timeline for. I'm gonna go back to my event graph. You can see now that I've got an output right here, a channel output. I'm just gonna grab on update, and I'm gonna do print. And I'm just going to drag the percent and I'm going to plug it into here for right now. And it's doing a conversion from a number to a text, essentially. So right now, all I'm going to do is, again, make sure that my timeline is working. So if we go and press play, I'll walk into it. And it's taking 1, 2. So you can see that value is increasing, decreasing as it goes, as we step in, step out. Oh, we haven't done the work to open the door yet.
Oh, okay.
So, all right. So one of the things that we need to talk about is that we want to work within the space that we are in. All right. So let's go back to our sliding door. Let's go to our viewport. We want this door to slide in this direction. One of the things that we could potentially do is rotate this. So I'm simply going to rotate this so I'm rotating this so that when we bring this this way now, and I'm actually going to copy and duplicate and unlock this. There we go. So I'm going to set this back to 0 so that we can see, so that we'll get the door right on both scenarios. All right, let's go back to the sliding door. So basically what we want to do, go back to the event graph. So on update, so when this update, we want to move our doors. All right, let's make our lives a bit easier. Let me delete these to start with. We'll work with the door reference. So door A. Basically, the door. So basically, the door location is basically essentially its starting location plus the slide amount times the percentage. So first of all, we know we got the slide amount. So I hit the multiplication sign. I use the star to get the multiplication. So basically, we know that this is the slide amount. This is essentially right here, the delta, how much is going to move this frame. Move the door, and I'm gonna back off. I'm gonna actually show you use for function. I'm gonna call this slide door. Compile it, and I'm gonna ask for 3 inputs. First one is the door. I'm actually gonna put percentage. actually need one more, and that's going to be the use location, direction. Okay, so this is going to be, so again, these are static mesh components. So what we're looking for is static mesh component. And it's going to be an object reference. It's going to be something that's in the scene already, in the scene of the blueprint. Move amount. This is going to be a float. Direction is going to be a float, and then percentage is going to be a float as well. All right. So basically, we're going to basically make a function to handle this. So let's go back to the blueprint. Let's set up on the blueprint so we understand what's going on. This piece right here, I'm actually going to cut and I'll go back to the slide door. So here's our delta. Oh, I don't need the move amount. Hold on. Let's go back, compile. Let's go back to the inputs. This is not move amount. This is the start location. And this is going to be, so my apologies, this is going to be a vector 3. All right. We know that we're going to move on the y-axis only, locally. So that's going to help us out. So let's go back to the event graph. So I can just drag out slide door, and then here is plug the door into here. We'll set up the start. The direction right now is going to be 1. And then we'll take the percentage and drag that into here. All right, so what we haven't done yet is we need to create two variables. Door A start. Door B start. And these are going to be these are going to be vectors. Now, I'm not going to actually, again, we know what this slide amount value is. And we don't need this to be editable. The door A start and door B start, essentially these are things we're going to grab at the beginning. So actually bring back begin. And I'm going to get door A start. I'm going to get a set for it. And I'll do the next for door B start as well. And essentially this is the path that it's going to do. All right. So door A, we're going to get a reference of that. Get door A. Get, and we want So we're going to get what's called the relative transform. So the transform the component relative to its parent. All right. If we get the world, so there is also get the world transform. There you go. Here is get world. And again, there's we do relative. Again, we could also got in the actually let's get the relative location. It's kind of what we really want, anyways. So this is basically essentially breaking this vector, the struct pin right here. And this is the relative return value location. This is the relative location. So I'm gonna delete this one. I'm gonna no, we'll go the other way. We'll do the actor pin. We can plug that in right there. So basically, again, we want the relative location. We want it relative to where the scene root is. If we get it the world location, we've got to deal with the world location and its world. So we wouldn't necessarily be moving on that axis. Like if we rotate 45 degrees, we're going to be rotating, and that's the other thing. I'll rotate one 45 degrees. I'm going to do door B. And we'll get relative location. I am running out of time, unfortunately. So I'm going to do this really quick. For door B, our direction is going to be in the inverse direction. So that's the only reason, the way we have this here. So this will be only 1 and -1. All right, so let's compile. Let's go back to slide door. So basically this is, we're taking our percentage, multiplying it by our slide amount. That's how much we've moved. We need to multiply it by the direction. So this is for door, basically if this is for door B, that direction is going to be a -1. So we're at, and then we're going to add, actually we need to, let's break the pin. Because again, we know we're only moving off on the y-axis. Let's bring this up. There we go. That's better. So we're going to add. I'm going to bring this down here. And then I'm going to set. There we go. Set relative location. And our purpose is right now, I'm going to split this pin anyways. So this is the new y, and then x and z are going to be plugged in here. And I think everything works. Save everything. Go up. mistake now. So the update here, I didn't plug into the door A. So one of the things, I'm going to place a new, we'll do a reroute. So basically, I've just made a pin floating in space. Make this easier. It's not going to do what I want to do. Just updated. Okay, I'm going to copy this. I'm going to grab, oh, and the other thing is the start location. I didn't plug in. Here's B. Door B. Direction is going to be -1. And then I'll grab the percentage and drop that into here. And I'll update. Oh, I gotta do. This is where the reroute node is going to be useful. Basically, I'm adding a pin here. I'm going to take the pin and drag it into here so that it looks cleaner. Compile. We'll go back to the map. There you go. And go back to. Yes, but let me go plug that in. I didn't. So they're both moving. Go in. You can see that the door is now both opening. And then. All right. All right. It is 2:00. Is there any questions before you take off? No. All right. I will see you in lab.